So today I want to talk about why and how to port legacy applications to Kubernetes. So this is going to be a practical discussion for mainly aimed at engineers and others who are porting existing apps to Kubernetes or thinking of doing it. So first of all, let's start with why you might be thinking of porting your app to Kubernetes. This is very commonly the real reason, and not a bad reason, but on the other hand, sometimes the boss isn't the most qualified to be making this call. Then the other big reason I hear from people why they move to Kubernetes is scalability. And it's absolutely true that Kubernetes is fantastic for scaling. However, it's kind of a side effect of its real benefits, and scalability may not be relevant or even important or the reason at all for some projects. So why do I want to talk about why? Because the why is critical to the success of the project. And in this talk, I want to be really, really careful not to insult your intelligence, because I know this is a cloud native meetup, so you guys already know probably the reasons why you would port an app to Kubernetes. But my experience has been that communicating the motivations is really, really critical to the success of the project. So I want to talk about what are the motivations and thinking about the motivations and communicating them. Because the improvement is often not visible at all to the end users. And ideally, in the long term, it should improve performance. However, anytime you take a complex system that's currently running in a particular platform and you move it somewhere else, you can get a performance hit at the beginning. And so you don't want it to be that happens and then everyone is like, what? Oh, Kubernetes is some garbage. What happened? Why do you do this? We did all this cost and you made it worse. So the important thing is to make it absolutely clear, communicate why you're doing it. And one of the reasons is you need to be able to get your management to prioritize the resources. Sometimes, they'll treat it as this little thing that's off in the corner and then, never have like the time or resources you need to do it. And so, I want to, as I said, manage these expectations, make it clear that if there's an initial performance hit, in some cases that you've already communicated that was expected and that that's not why we were doing it. And then also, the other thing is to get your colleagues on board. So, I mean, I think most people here are engineers, so I know that as I said in the first slide, a lot of times, so you're supposed to move it to Kubernetes, so you'll do it. However, if we're engineers here, we're thinking about, is this a good solution to the problem? And if you're not convinced that it's a good solution to the problem, then that absolutely will impact the energy that you bring to the project, and putting your best work into it. So if you're the one who's convinced, yes, we should get it, port this to Kubernetes, then it's actually valuable to communicate that to your colleagues whose assistance you will be needing. And then there's a final reason, which is maybe it isn't the right choice. I'm a huge, huge fan of Kubernetes. However, my biggest motto in engineering is use the right tool for the job. And there can exist cases, yes, where Kubernetes isn't the best choice. So you should be thinking about, what are the advantages of moving to Kubernetes? Are these advantages relevant to my project? Because the objective is never, we're moving it to Kubernetes for the sake of moving it to Kubernetes. We're moving it to Kubernetes. The objective is the success of the project. So if that's what's going to help the project succeed, then we should do it. Otherwise not. So then, again, not to belabor, we can talk about some of the wrong reasons why you might be thinking of moving your project to Kubernetes. One of the things that put me off of Kubernetes when I first encountered it, when I first heard of it, was a colleague said to me, okay, oh yeah, we have to do this because Google is doing everything on it. And my first reaction to that was, okay, well, their use case is like 1 billion hits a second, so that's not my use case and never will be. So if this is for that, to make that happen, then maybe this is premature optimization. But yeah, so that's not a reason I would think would be very convincing in general. And also, you're hearing about Kubernetes all the time, so maybe we should use it, this hype-driven development. Personally, I really hate hype-driven development. I mean, I consider myself fundamentally an engineer, but as an engineer, I'm a little bit of a Luddite in the sense that I don't like gadgets for the sake of gadgets. I like, what I love is an elegant design that solves the problem at hand in a simple and efficient manner. And so you hear about all these different things that are overhyped. You can probably think off the top of your head some items that are really hyped right now, maybe some things where I would say seem like a solution looking for a problem. I've been in this biz, in software engineering biz, for about 25 years, and I've seen a lot of stuff that's hyped that just goes absolutely nowhere. And so, I mean, just the fact that everyone's talking about it is not going to convince me that it's something that we should use. However, I want to make a distinction between hype-driven development versus something becoming an industry standard. And sometimes there are different tools, different platforms where you hear about it all the time, and the reason you hear about it all the time is because everyone's using it, because it has become the industry standard. Now, I think in the case of Kubernetes, even though it's a relatively recent, relatively new tool or platform, it's quickly becoming the industry standard. And in contrast with doing stuff because it's hype-driven, looking into a tool because it's basically industry standard actually is all by itself already a reason to at least consider it. Because if something is the industry standard, number one, you know, I mean, it must work at least reasonably well for some projects, for some applications. Otherwise, it wouldn't be taking off. And then additionally, if this whole broad spectrum of people are using it, then when you encounter a problem, you know someone else has already encountered it, and that you can do a quick search online and find the solution. Or even better, probably someone already encountered the problem already fixed it before you ever even see it. So just because something's industry standard doesn't mean it's necessarily relevant to your specific project. However, it is a reason where you would, you know, actually at least take it into consideration if it's one of the proposed possibilities. Okay, so I'm gonna have to skip past this one in interest of time. I can go back to it later. I have some amusing, I think amusing, let me back this up, insights about this book, which is a seminal book about DevOps, but we'll come back to it if we have time and questions. Okay, so let's move on to the real reason why you would use Kubernetes, which is because of it modularizes the layers, infrastructure layers. It's the modularization of the infrastructure layers. Specifically, we're breaking unnecessary dependencies. So like a lot of DevOps, this modularization really is, in some ways, it's porting an idea from dev onto the ops space. Because, you know, if you guys are in software engineering, maybe some of you are, probably all, at least a bit. So, you know, if you have like the code that is making, that's like the display of the view of a web app, you're not going to want to put a complex SQL query straight up in that class, because then your interface is strongly dependent on the specifics of the structure of the database. And you obviously want to be able to split those up so you could completely potentially swap out the data source. And so we have the same situation on the server side well, I don't want to say bad old days. Okay, so what we used to do or the standard that still happens is, you know, it's still happening on some layers, is you have a bunch of multiple processes that are all on the same machine. So you have your server, and you have this whole array of different processes that are running on it. And the problem with that is that they impact each other, they affect each other, and then you have a dependency that isn't relevant or necessary. So you can have one process, for example, maybe it requires an upgrade in order to work, but then you have a different process that was running on that machine that the upgrade breaks it. Or, for example, you can have issues that are hard to identify because there's so many parts that are strongly connected to each other that it becomes hard to pin down a specific problem. Or you can have resource allocation problems where one process is hogging too many resources, or even something as simple and stupid as rebooting. You can have an app where, okay, this part actually, we kind of should just hard reboot and start over, but then if it's on the same machine with everything else, then everything reboots. So everything, so these dependencies, are unhelpful. It's nice to be able to break them. Containerization all by itself takes us part of the way. Because so now we have containers. The objective is to try to isolate each specific process in its own container so that if there's an issue, you could potentially move the containers to a different machine or whatever, or change the resources based on different containers. And of course, containerization goes a huge long way towards eliminating the runs on my machine problem, because you have, if you have a complex application and it requires this whole sequence of setup for the specific machine, then there's always something about the machine that maybe was not obvious or was not clear, and then it doesn't run somewhere else. So the beauty of the container is you've isolated like one process with its complete environment. So you really do successfully get the right ones run everywhere. However, this is ultimately just a part of it if you're running all of the containers like in a standard containerization platform, such as like Docker, for example. So Kubernetes takes it to the next step. And so I assume you guys all are familiar with cattle versus pets. Everyone, because I was telling this to various colleagues, and interestingly, they had never heard of this metaphor. but anyway, so I mean, just to review, in the olden days, we used to have like a set of servers. Every server has its own name, like a little pet that this one is the dev server, this one's the prod server, this one's fallback server, this one's maybe production database server, whatever. And so there's a whole series of processes that are associated with this one job that are associated with this one specific server. And so then you get this extra dependency that is unfortunate. And so then the idea of this metaphor is that instead of having each server be a pet, they should be more like cattle, so you can have a situation where you can swap one out, they're basically equivalent, it won't matter. This is, of course, why Rancher is called Rancher. And so we have the Kubernetes cluster really moves us in this direction of being able to swap things out very, very easily, because the Kubernetes cluster, it abstracts the network of physical machines. So in the same way that the container is like, it's like a very, very tiny virtual machine running just this one process, then the Kubernetes cluster is basically like your own private network that's in your building or whatever, and it's not just metaphorically like it. It follows these same protocols. So one of the nice advantages is that since it's using the same protocols as the whole internet and the intranet, we know that these are time-tested protocols, and that it's been working. They've been working very well for these large distributed across the cloud types of applications. So you can do the same thing locally in your own little Kubernetes cluster, which also has the advantage that, for example, the same people who've been doing networking forever, the same engineers, it's very easy for them to port their skills to Kubernetes, vice versa, have the same engineers working on both, because a lot of times you do have both layers that you have to deal with. And it makes it so that since a Kubernetes cluster is abstracting basically, any standard network, then anything you can run on regular networks, you can essentially just do the same thing in the same way for Kubernetes. But then Kubernetes adds one additional step on top of that, which is the container lifecycle management. And so this is one of the biggest advantages, because, in the olden days, even if you're using virtual machines, it's typically like a whole procedure when you set up a new virtual machine. So, I know there are people who are working in major data centers that may have like some automated processes, and of course Ansible scripts speed it up, but usually it's a manual process even of deciding when you would make a new VM, and then it's a whole thing to like make the new VM and such. But so with Kubernetes, it's so easy to spin up the new containers at any moment that you can actually automate and just make descriptive manifests explaining when they should spin up. You can spin them up based on load, and you can spin them back down again based on load. You can say, okay, I want this to run at a certain time, and then the container spins up, it runs as long as it wants to, and then it goes away. So we have the obvious beneficial side effects. Because it's so easy to spin up containers, it's very, very easy to scale. As I had said earlier, you can automate the scaling and have the scaling happen based on load, for example. That's very common. And because it's so standard, it's also very, very portable. And this, I think, this is one of my favorite parts, and this is, I think, advantage that Kubernetes does have over some other competing containerization platforms. I can develop a set of manifests for my particular set of pods that work together to make an application. I can develop these manifests for my personal private hobby cluster that I have on Linode, and I can take those literally this exact same manifests and just apply them on the Rancher cluster that we have at my current job, or on the Google Kubernetes engine cluster that at my previous job, without even changing a thing. And I can just hand them to other people or put them online, and they can do the whole thing. And then one more part about the scaling is this efficient resource sharing. Specifically, you get the scale down as well as up, this is particularly relevant when we're talking about porting legacy apps, because a lot of times you'll have a legacy app that needs a very special environment, and it needs to keep running for whatever reason, you have a contract or whatever, but it actually doesn't really have the load to justify a full VM. And so then you're running the VM all the time, for whatever the peaks, but you're wasting some energy. Whereas you can put it in one little pod, for example, and then while it's idling, it scales down to almost nothing, and you can put it in the little corner of your cluster, and it's costing you very little. So that's just the philosophy. I hope I didn't insult people's intelligence too much with all of that, because it should, I think, probably stuff you guys already all know. But so anyway, though, just to reiterate, how you could communicate it to your teams and such. So I'll just move on to my real life examples. I have 3 different projects where I ported existing apps that were already running in other systems to Kubernetes. The existing apps that I'll talk about, we had an internal app which I shall call the Grandma app. We had an app which I shall call Project Quick and Dirty, which was replaced by the Phoenix project, and then a third project which I will call Docker Redo. Now, none of these are the project's actual names, except the Phoenix project. Oh, what's that? Oh, okay. Okay, so except the Phoenix project. So this is a pro tip. Don't call your project the Phoenix project. No, I'm not gonna say the name is cursed. However, there's something about this metaphor of, okay, our project is gonna rise from the ashes of the thing it's replacing that creates a lot of expectations, both positive and negative. And I would say, don't saddle your project with that right out of the gate. So anyway, let's talk about the Grandma app. Okay, so this was an app I encountered at my previous job. The app was an internal app used within the company. It was 10 years old, which is 100 in app years. And it was one of those things where it had been started during startup mode of the company, and just more and more stuff piled on top of this thing that had been made at first kind of quick and dirty itself. And so it just had massive technical debt. And when I saw it, I thought, oh, okay, well, they're going to replace this right away. But there wasn't any plans to replace it. And so one of the things about it was that the app itself was running in its own VM, but the VM, it contained not only the app, but also the web server that was running the app, the database itself, and also the test deployment. So they had only one additional deployment for staging and testing, and it was on the same VM, using the same database server. And they didn't have a fallback, no fallback at all. And so this went very early on when I had arrived at the company taking on a DevOps role. I got an alert on a Saturday when I was like setting out to go grocery shopping, that the production system's down. So I rushed back home, and the disk was completely full. And it was to the point where the production app would not respond because there was no more space for database writes. And so, yeah, I was like frantically finding files to delete off the VM. Fortunately, I found a big packet of useless files that I could delete that cleared it up for like a couple of months. There was like a .git tree on there because some people had been deploying it like directly like by logging to Git onto the VM. And so this huge history of all the code in a folder, I deleted that. And that gave us another couple of months. But I was like, okay, yeah, I'm not okay with continuing to be responsible for this thing in the state that it's in. But one of the issues for trying to fix it was getting the prioritization, because the manager of the team was pretty young and pretty inexperienced. And so the developers on the team had been saying, we really, really need to focus and have time to pay down some of this technical debt. We need to be able to really focus and clean this up and get it up to speed. And the manager of the team was like, oh no, my clients, who are internal clients, they need this feature, they need that feature. We have to prioritize new features. And so, yeah, I mean, ultimately, I ended up, unfortunately, having to have the meeting with me, my boss, that manager's boss, and the devs, in which I explained to that manager's boss that the state the app was in was in danger of catastrophic failure. There's no backup system, and I'm not going to make there's no fallback system. I'm not going to make a fallback system for this garbage. I'm just moving it to Kubernetes because we already had other apps on Kubernetes. It was much, much easier to do it. And I don't like to have that meeting because I feel like it demonstrates a failure of communication and a failure of collaboration. So hopefully you will communicate better and earlier and not get to that point. But it did work. It worked, and we managed to convince the manager that the devs could spend basically half of their time on fixing the stuff up. So we moved it to Kubernetes, and then once it was on Kubernetes, it was much, much easier for the devs also to try out new ways of optimizing, because they were able to have multiple dev deployments running in parallel that they could try stuff out on, instead of having this thing where they have one staging deployment that, in fact, internal people were testing with, and that it's on the same VM, so some stuff they do on that VM could impact the production system, et cetera, et cetera. So they were able to do a lot of optimization because of the fact that it was on Kubernetes. However, it did, the initial move did cause a performance hit. So we had an issue where, because it was on a VM, everything was together, the database, the file system, everything. Just simply the fact that we were moving it to a system where the app is in a pod and the database has a tiny but non-zero latency, and there was a lot of database hits, and the file system also, and it actually had some performance degradation at first. In the long run, it was easier for them to optimize things, but there was an initial performance hit. And this is why one of the tips I would say is it's really critical to have benchmarking and performance testing of the system, so you're timing exactly how long things are taking, and you want to know how much resources it's taking, because you don't want to be in the situation where you move it to the new system and then everyone's like, I feel like it's slower, I feel like its performance is not as good, and so it's crap or whatever. So you want to be able to point to your benchmarks and say, yeah, okay, we do have this additional latency and it causes this such and such performance slowdown, but this was expected, we already planned it, and we're going to move forward and fix stuff. We'll be able to fix stuff moving forward. But this was, I feel like a success story. We moved it to Kubernetes, it was better on Kubernetes. Then the next one I would talk about is Quick and Dirty versus Phoenix. This one was a funny one because, okay, so I was working for, this is the same company as the other one, not an internal app, this one was for external clients. And when I arrived in the company to basically set them up with Kubernetes, they already had this one app for clients. It had several components. A couple of the components were actually already on Kubernetes when I arrived. My first project was to move the rest of it to Kubernetes. And we moved it to Kubernetes, and it was basically completely on Kubernetes, and just like the same week that it was finally, everything was beautiful, everything on Kubernetes, then the project was declared end of life. So what happened was that parallel to while I was moving to Kubernetes, the company, which is not a tech company, got a bunch of money from a source that had nothing to do with tech. And so they decided they were going to reinvest it in their digital offering, which is, I mean, I think probably not a bad decision. But then what happened was then they hired a bunch of new people for the team. And then the new people took one look at the Quick and Dirty project, and they're like, oh, no. Oh, hell no. They're like, okay, no, we're starting over from zero. We're going to have the Phoenix project, which, again, is not necessarily a wrong decision. And I mean, I don't want to shit on them because I feel like they're good engineers and they did make something good. However, 3 years later, I was still getting messages from sales saying, oh, hey, we got another client. Can you add it to Quick and Dirty? And I'm like, do you know what end of life means? And what happened was, you know, the Phoenix team, they did make something, but it never had, it never quite, even though it was named Phoenix, and this is why I have the problem with the name, because it was supposed to replace the old one and we could shut it down. But it never achieved feature parity, and so they never moved the clients off of the Quick and Dirty system 3 years later, which we had been expecting that it was going to get shut down. And so what happened was that, you know, when they decided to make the new project, raise from the ashes of the old project, you know, a lot of the original developers felt very unwelcome and they left. So it was just one guy who had been part of the original dev team and me on DevOps. And he actually, the one developer, he actually obviously didn't want to be working on this old project that's going nowhere. He wants to be working on the new stuff. And so I was really glad we had moved it to Kubernetes because it absolutely simplifies upgrades if you don't have to upgrade it in place. If you can spin up the new container and make sure that it's working before you swap stuff over. Because we absolutely did, in the course of those 3 years, have cases where we found really, really critical security bugs that, I mean, it was like emergency to patch it, you know, and I ended up like having to, you know, do some debug myself. And it, like, even though sort of technically not the dev on this, I'm the DevOps, and, you know, I was in JavaScript and PHP, my favorite languages. I had to dig through and find some of the issues, and then help rebuild it with this other guy. He was great. He was very helpful, and it was fun teamwork. But if we'd had to upgrade in place, it would have been dead. And so, yeah, I was very happy that it was very nice we were able to do it simply and do this replacement with Kubernetes. The promised replacement never materialized. Okay, so the last one I'm going to talk about, which I'm calling Docker Redo, this is my current project in my current employer. So basically, I was hired largely because they wanted, you know, a Kubernetes expert, because they had a project, they have an application that's running in Docker, a combination of Docker Compose and Docker Swarm on a series of VMs. And so they want to port it to Kubernetes. And so I'm basically like, hey, no problem. That's the easiest thing in the world. You just have your little container. It's living in this one platform. You just pick it up, put it in the other platform, you know, just translate the manifest, and we're done. But the problem with this project is that the container isn't just sitting on Docker. It's actually strong. The app itself is strongly intertwined with Docker. The app itself calls the Docker API and launches other containers in Docker. So yeah, so it's a little bit problematic. So I can't. So in order to get the system up and running, like a barely, so it's like a barely running version. I had to actually create a dink pod. So, you know what Docker in Docker is dinned, and also kind Kubernetes in Docker. And to make this thing run, I had to make Docker and Kubernetes, which is, I took the DIND pod, the Docker and Docker pod, container, and put it with the app to get in a different container in the pod, and then they share the Docker sock, and then the app is able to call the other one. So we're thinking that this probably isn't going to be production worthy. So this is, the objective is going to be to isolate the Docker code. We're right now working on this, and separate it out with an interface, and then have like a Kubernetes version. But we'll see. We'll try them both side by side. But this one, it was designed for Docker, and it strongly relies on some advantages of Docker. It's like it's really, really important for this app to be able to spin up a new container like that. And Docker is just faster at that than Kubernetes because Kubernetes has overhead. And so in this one, it's actually super critical to talk about or to think about why we're doing it and what advantages we're trying to get, because the costs are so high. Because we have to do extra dev, we have to change the app itself, and we'll almost certainly get a performance hit with respect to spinning up containers. And so, yeah, this is why we need to talk about what are the advantages we're trying to get from it, and because it helps us plan like how fast we're doing it, which clients we're going to move first to the Kubernetes version, and how to do the two in parallel, etc. So, yeah, that's a current one. And then, so now with that, we'll conclude on talking about what are the right reasons for moving your app to Kubernetes. And the same reason you would basically make any other major change in an existing app, is it cheaper to do it than not to do it? And so some of the reasons why it might be cheaper to do it, for example, if you already have Kubernetes infrastructure. So in the previous company I was talking about with the other two apps, the Phoenix project and the Grandma app, of course, because of this original quick and dirty app project, we already had Kubernetes infrastructure. Obviously, we already had Kubernetes expertise in-house. And so because of that, there's like a whole bunch of other like little apps, like just little tiny apps that are kind of a little bit used and not really, that were on their own separate VMs all over the place. And in this case, it was simpler to just move them all to Kubernetes, because that way it was easier for me to keep track of them all, make sure that they're all updated, et cetera, et cetera. So if you have that, then I would say very high probability that is worth it to move whatever random legacy apps you have to Kubernetes. If you don't, and you're starting from zero and you don't have Kubernetes infrastructure or expertise, then it might be less of a good idea to move your legacy app to Kubernetes. Then, of course, for a legacy app, you also ask, how long is it going to be in use? Maybe it's not worth it. Yeah.
Great. The previous point, how did you choose the which client you moved to Kubernetes first? How did you prioritize?
Well, in fact, we're still working on it. But okay, I will tell you, the ones for the current project that I'm on, one of the main points for how we're prioritizing it is we have some people who their projects are going to be hosted on a separate site or hosted themselves. And so these guys are new and they want hosting that isn't in our current infrastructure. So they are obviously the first ones to go. So yeah, they're the first on the list for Kubernetes. Yeah, so as far as as I say, if you're sure they're gonna unplug it in 3 months, then maybe it's not worth it. However, from my previous example or my experience with not just this Phoenix project, but a lot of projects, they promise, oh, well, you can fully unplug it in 3 months, and then 3 years later, it's still there, So I would take that with a grain of salt. If you feel like it's easier for you. I mean, for me, if I have something, they say it's going to be unplugged in 3 months, but I have to do a major fix to it, I would be at that point, okay, no, I'm moving it to Kubernetes. I'm not doing a major fix in place on this crappy old infrastructure. And then if they make you keep it running for another 3 years, it's less of like a crisis every single time it needs to be upgraded. So yeah, because you get the easy maintenance and upgrades. And of course, the other advantage, as I said, specifically for legacy apps, is the scaling down. You can keep a whole bunch of them idling in a little corner of your cluster, and they're not like wasting a lot of resources. Okay, so yeah, that's it. And any questions?